So today we're going to do all of the transformations. And this is the acronym that I usually talk about is HIVO. I realize that's not a word, but neither is PEMDAS and neither is SOHCAHTOA. It's just a acronym to help you remember stuff. Did your teacher use that before or something similar? Okay. It means that the horizontal changes happen inside the function. The vertical changes happen outside the function. And I'm going to also add on to that, the horizontal changes affect X and the vertical changes affect Y. As a heads up, this first page is going to take us a little bit of time to get through because I'm going to put all the information you need in one place. So we're going to kind of this is going to take a little time to get through page one. After that, when we start doing some actual problems, it'll speed up a little bit. Okay. So vertical shift, vertical is up or down. That's going to be outside of the function. You can have your function plus C or your function minus C. C is just a placeholder to represent a number. When we do an actual problem, there will be a number there, like 3 or 7. Okay, it'll be a value. If you add, it's going to move up that amount, up C. If you subtract, it's going to go down. So it makes sense. It's logical. Plus means up, minus means down. And those would affect the Y values. So if you go up, you're going to add whatever that amount C is. Again, I know it's annoying when it's C. When we do an actual problem, it'll be a number. But you're going to add C to the Y value. And when you go down, you're going to subtract C from the Y value. But it's the Y value because it's outside of the function. All right, so outside affects Y, it's vertical. Horizontal is going to be inside, and those ones are kind of backwards, okay? So you can have X plus C inside the function or X minus C inside the function, but those ones are kind of opposite of what your intuition would tell you. So the plus C is going to move you, what direction? Start out by asking you. Good, that will go left C, and the subtraction will go right C. All right, and so since it's inside, it's going to affect the X value. So if you're going left, you're going to subtract C from your X value. If you're going right, you're going to add C to your X value. Again, kind of backwards, but it's affecting the X's because it's left to right. And again, I'm bringing up every last little detail of this now so that everything you need to know is in one place on this sheet. So we're kind of writing it. All right, reflections are done with a negative. The negative can be outside or the negative can be inside. So you can have a negative before the function, or it can be inside the function. When I say inside the function, if you have an absolute value function, it would be inside the absolute value. Or if it's exponential, it's inside the exponent. Or there's parentheses around it. It's stuffed inside of the function. Now it's still horizontal inside, vertical outside. So see the negative outside? If you reflect something vertically, so if you have a graph up here and you reflect it vertically, which axis did you go over? The x-axis. So if you reflect vertically, it reflects over x-axis. And when it's outside, it affects the y value. So you're going to multiply your y value by a -1. Or you're going to opposite your y value. Whatever was up here is now down there. And then the one inside is the exact opposite of that. So it's going to reflect the y-axis. It would be the opposite of this picture that I drew right here. If you reflect horizontally, you go over the y-axis. And you would multiply your x value by -1. I think that's like one of the harder ones, is the reflections. Like the shift is not too bad, but like the reflections can be tough. It comes through practice. I think in Algebra 2, you do the vertical dilations, but maybe not the horizontal, or maybe you did both. You'll have to let me know what you remember. So vertical is outside. You're going to multiply by something outside the function. Like these ones we added or subtracted. Now we're going to multiply. So I'm going to multiply by c outside of the function. Or it could be a fraction, 1 over c. Again, c is going to be valued. So it would be a 2 or a 1/2 or an 8 or a 1/8 or something like that. Now the word stretch or shrink just comes through how we talk. Don't get hung up on the word stretch and the word shrink. Like that just comes from how we say things. Like I wouldn't say, I put this shirt in the dryer, it shrunk, it's now twice its size. Do you know what I'm saying? Like just don't get hung up on the word. It just comes from like naturally how we talk. Here, it's a whole number, you're making it bigger. Oh, I have a sleeping that I used for it. Here, this is what I used last year. You take the ground and you did this with it. Did you stretch it or shrink it? Stretched it. Okay, so this is a vertical stretch by whatever C is. You'd say vertical stretch by 3. It's 3 times as tall. And it was outside, so it's going to affect the y value. So you multiply your y value by whatever C is. So you're scaling it. It's kind of like, you know, there's like the actual Eiffel Tower, and then you can get a keychain of the Eiffel Tower. It's like scale, like you take that and multiply it by 100 or whatever, then it's the actual size. And then this one's going to make it smaller. So if I take something and I squish it like an elephant sat on it, I shrunk it. So it's a vertical shrink by 1/c, 1 over c. So you would say I shrunk it, it's now half its size. So the shrink and the like fraction of a half go together. And again, it's outside, so it affects the y value. Multiply y value by whatever that fraction is. And then the last one, the horizontal dilations. Horizontal means it's going to be inside. So you can multiply by a value inside or the fraction. Did you do those last year in Algebra 2, the ones where it was inside? I'm not sure if you do those in Algebra 2 or not.
They're mentioned, but not very much.
Okay, so like you saw it, but you didn't really do a whole lot of problems with it? Okay. Because I feel like that was the one thing that wasn't done in there. Anyway, it's inside, so it's going to be horizontal. And just like the shifts left and right, it's kind of backwards to your intuition. So say, and it's hard when it's C. Say that was a 4. You would flip it and it would become a 1/4. So we use the word shrink. If something is a 1/4 of its size, we say shrink. So this would be a horizontal shrink by 1 over c. If you're talking about a fraction, you need to use the word shrink because that's how we say it. Again, I wouldn't say I shrunk something. It's twice as big, you know. Now, because it's inside, it's going to affect x. So you're going to multiply your x value by whatever that fraction is. And then the last one is exactly what we just wrote, except the opposite. It's going to be a horizontal stretch by c. Again, you're flipping it. The inside ones are kind of backwards. And you would multiply your x value by c. So quick recap. If something is outside, it's vertical and it affects y. If it's inside, it's horizontal and it affects x. That's everything all in one place for you. Are we okay? I was like, we threw a lot of information at you. I really like this little explanation or like exploration here. I'm gonna use that as a warm up for next time. So next time we're gonna do this as a warm up. Are we clear on that? So don't like lose it. But I want to have time to focus on like doing some actual problems. So I usually get a different color. You can or not, whatever you want. And I'll kind of either like highlight or circle the like main function part of it so that you can tell what's inside and what's outside. We're going to state the parent function. That's a word like we were doing with Battleship. Transformations, and then we'll draw a graph. So here is the actual function so you can see what's inside and what's outside. So what's it called? And the word is rational. Ratio is the root word's fancy word for fraction. And there were two things done to it. There's a negative. Do you see how it's outside? Because that's the big thing. Is it outside? Okay. Outside, I'm not testing you yet. You can flip back to what we just looked at. When the negative's outside, what did you reflect over?
Yes.
X-axis. Good. So it's reflect X-axis. And the +3 is inside the function. Do you see how it's inside the box that I put there? That's why I recommend doing that. You can see what's inside and outside. So it's inside, that means left or right, and it's backwards to what you would expect. It's backwards to what you would expect. Left 3, good. So when you go to graph it, and this is the tough thing, and here's my pep talk. This is your first time graphing without a calculator. So we're going to look at it today. Next class, we are not learning anything new. We will simply practice graphing because I know that it's a difficult topic for you guys without the calculator. We will just do nothing but practice that. So if you're worried about it, don't, okay? I've got you. What did the rational parent graph look like? The one that we looked at last time that we didn't shift at all. You're thinking, I'll take that. Remember the asymptotes? And it was like the hourglass looking thing, okay? Now, typically the asymptotes were on the axes, but this one went left 3. So instead of being right in the center, you're gonna go left 3. 1, 2, 3, I can't talk and count at the same time, and dot that in. Now it didn't shift up or down, so this one's gonna stay where it is. It didn't move up or down at all, but we just shifted it left 3. And then you're gonna kind of need to watch these points to this part, because I don't really have a better explanation than, hey, look. Do you remember how, don't draw this. Do you remember how it would have been here and here? But it'll be the opposite of that because of the reflection, okay? So you're gonna draw in the arms of the graph on the other 2 spots. So your graph will look like this. So it went left 3, and then it was reflected. Cool, you did it. Let's try it again. What is this one called in words? Word form. Absolute value. You can abbreviate as much as you want there or even on a test. The reason I said don't abbreviate on the game is because people complain like, well, they abbreviated and I wrote the whole words. Now, also, let me say this. I'm going to leave you the correct number of lines for answers that there are. I always get somebody that adds in an extra line or something. Don't do that. I'm giving you the appropriate number of lines. Okay, so there's 4 things that happened here. Can anyone give me one? I don't care what order they're in. Good. The 1/2 outside. Outside means vertical. And if it's half its size, that's a shrink. So vertical shrink by half. It's like an elephant came by and sat on it like this, like it was here, and we squished it down. All right, what else? Again, I don't care what order. Go ahead. Or that's not for you to go? Go ahead. Reflects y-axis. The negative is inside. So reflect y-axis. The +2 is also inside. Again, remember that's kind of backwards. So left 2. And then how about the -3? It's down 3. Good. So what shape is an absolute value normally, like the parent function? It's a V shape. Okay, but instead of being at the center, we went left 2 and down 3. So here's how you do it without a calculator. Instead of being at 0, 0, from there, you're going to go left 2 and down 3. That is now the center point of the V shape. That's kind of, if you're like, why on earth do we know this? Once you know the transformations, you can graph very quickly without a calculator because you're like, oh, it just went down here and now it's the other way or whatever. All right, now it also reflected the y-axis. Here, look at this and I'll act it out. Here's a V shape. If I reflect over the y-axis, what happened? Yeah, it's the same. So you kind of don't need to worry about that. And then the shrink by a half, you can use that as your slope. So from that center point, go up 1 over 2 in each direction and just go like a couple of points and that's good enough. But what you want to notice is, hey, it looks like it got flattened from what it was originally. Yeah, it's just that a V, when you reflect over the x-axis, it would be upside down. So it would go this way. But if you reflect a V shape over the y-axis, nothing happens to it. So you, like, it's like, yeah, it happened, but you can't really see it. All right, we're doing good on time. All right, this one is what? In a word. Good, perfect. Exponential. You can abbreviate here. I will accept that, that's fine. There's 2 transformations because I gave you 2 lines. So what's one thing that happened? Good, the negative's inside. It's inside the exponent. So reflect y-axis. You've got this. And those are hard, I think. I think the reflections are the hardest one. All right, and then the -4 is down 4. I feel like that's the easier one. So exponential is a swoop. I always go like this while I'm talking about it. Just remember your idiot math teacher up here going, okay? So instead of having the horizontal asymptote right there in the middle, go down 4 and dot it in. And then we're going to need to make a table of values for this one. You can plug in whatever you want. If you get something unpleasant, you'll just try something else. But what's a good number to start with? 1 or 0 is a good number to start with. Let's start with 0. I heard both of them. When you plug in 0, and this is what you got to be able to do without a calculator. -0, 0, right? Anything to the 0 power. Anything in the world to the 0 power. 1, good. 1, and then 1 minus 4 is -3. Good. So we got 1 point. I want to get a couple more. Now you said to try 1 next. If you plug in 1, you're going to end up with 3 to the power -1. Would anyone like to deal with that? Let's pick something else. Pick a different number. If you get something you don't like, just pick something else. That's all. If we do 2, you'll have 3 to the power of -2. Good, there we go. So if you do -1, if you plug it in, you'll have -1, which is 1. Good. 3 to the power 1. I know, like it's cold. It's too late in the afternoon for this. 3 to the first is 3, and then 3 minus 4 is -1. And then I want one more. Good, you got there. -2, just be 2. 3 squared, 9, and then 9 minus 4 is 5. When you plot those, it should swoop. It should swoop downwards instead of upwards. Because why? Because it's flipped. Oh, and I forgot to put my boxes around the insides of the function. All right, how about number 4? It's that double absolute value bar, like the bolded one. It's the one you hadn't seen before, so if no one remembers it, I'll just tell you. It was greatest integer, good. And it looks like a staircase. I like these for the transformations because it really shows you the stretches and shrinks like very visually. What happened to this one? There's 2 things because I left you 2 lines. Perfect. Up 1. Good. It's vertical because it's where? On the outside. Beautiful. I can tell you guys are tired, but you're hanging with me. That's awesome. I appreciate you. We should bring like candy to this class. So instead of starting at 0, 0, you're going to go up 1, put a point. And that's where your first step is. And I get that it's super tiny. I'll like bring this in. So that's your first step. Now they got stretched vertically by 3. So when you do your next step, from this open circle, I'm going to count up 1, 2, 3, and that's where the next step falls. So it would be a staircase that would give you a pretty good workout, like the steps are really far away from each other. So they're still only 1 unit in length, but they're further apart from each other. And if you're struggling with where to put the points, don't actually connect them, but watch me do this. Do you see how if I drew this line down, they would connect? Like, don't do that, but do you see what I'm saying? Like, if you're struggling with where, like, oh my gosh, this is floating, where on earth do they go? Like, you can always do that and then erase them if that helps you. I think I only made you graph 1 more. Yeah, then the torture will be over. I'm sorry. I did another one of these to compare and contrast. You don't have to write greatest integer again if you don't want to. It's the same as before. But what happened to this one? What's that -3? Down 3, good. And then the 1/2 is inside. Horizontal. Now hold on. They're kind of backwards. The ones inside are backwards. If you flip 1/2, you get 2, and the word we use for that would be stretch if it's twice its size. So horizontal stretched by 2. So, and again, I like doing the step ones for these so you can see the difference. They're only going to be 1 unit apart, but the step themselves get stretched. So it's stretched this way. Okay, so go down 3. That's your starting point. And the step itself has been stretched to 2 units. So they're still only 1 apart from each other. But the step itself is now 2 units wider, which I feel like would be an annoying staircase to walk up. I feel like with the deep steps, I feel like I would keep tripping over my feet. Okay, we're not graphing anymore. The rest of these are just like answer the question. Good, good. That was awesome. All right, so it says write the equation. That means you're going to need an f of x equals. We're going to take all the ingredients and just put them together. So cube root, perfect. Draw yourself a blank cube root and we're going to just fill it in. We want a horizontal shrink by a 4th. Okay, first of all, if it's horizontal, where does it go? Good. That means instead of a 4th, we're going to put a 4. So you're going to put a 4 inside. And then it also went right 2. Left and right is also going to go inside. It's kind of backwards. So for right 2, -2. And you also need to give it a hug. It's going to need parentheses. So it's going to be x minus 2. The reason you need the parentheses is because it all got shoved inside of the function. And you have to keep that separate from the 4. I'm not hearing any complaints. I'm going to just keep on going. All right, f of x equals logarithmic. So you're just going to write the word log. And I'm gonna draw some blank parentheses just because stuff's gonna have to go inside of it. All right, so let's see, reflected over y. Where does the negative go to reflect over y? I know it's one or the other. It's gonna go inside. Did this just get drilled into you last year too? Or no? Coming back to us? I don't know. Vertical shrink by a third. Vertical means outside, so that 1/3 goes outside. And then up 8 would be a +8 where? On the outside. Now there's one thing I didn't put in yet because I wasn't quite sure where we were going with this, but what else do I need in there? Yeah, like you have to have a variable, so you have to have an x somewhere. But you're just kind of assembling it. And then for these last ones, I gave the graph. You're listing out all the stuff. So you have it visually already. You're just going to list all the things. All right, so what do you think about number 8? Perfect. Square root. Now the center is normally at the origin, but it went what direction? It went right 3. Good. So you're looking at this center point, or like the beginning. Now also the parent function usually looks like that. So good, reflect over y. And then we're just going to put it all together. So f of x equals, draw a blank square root. And then what's going to go where? Negative inside for the reflection. Oh, it will need parentheses. X minus 3, you have to give it a hug because that's also inside. And you have to keep it separate from the negative. You're just sort of building the thing. I usually say this when we get to the last problem. When we finish this last one, I have one other thing to say, so don't stop listening to me immediately, okay? I know you're like, is it cubic or cube root? I know it's one or the other. Cubic, good, because it's right side up, but good, you guys got it. There are 3 transformations. I would get the center first. Instead of being at the origin, it's now over here. This is your center point. Left 2, good. Down 1, perfect. Now the parent function looks like this. So, okay, it could be reflect over x or reflect over y. They're actually both correct because it's symmetric every which way. Do you get what I'm saying? It's not going to matter. Pick x if you have a choice. So pick x if you have a choice. And here's why. I don't care which one you put, but whatever you put, your equation has to match. And it's a whole lot easier to put a negative outside than inside. So if you have a choice, pick x and put the negative outside of the function. So what's going to go in those parentheses for the left 2? Kind of backwards. X plus 2. And then outside. And then there's one other thing. The exponent needs to be cubed. Okay, don't stop listening to me. I have one other thing to say. This back here is matching. It's self-checking because if you do it correctly, you will get it to say a phrase that it's called a droodle. It's a caption for the picture. Droodles are a whole thing. If you want to Google that, there's a lot that are kind of funny. So this is there for you to practice and you'll be able to check yourself. You don't need me to give you the answers because if it spells something, then you know you got it right.